so you can start class now. And I have to remind you, we have some assignment this week. Okay. Assignment this week. So we have the assignment online homework. So from 6.1 to 6.4, no, 6.2, 6.1 last week, 6.2 to 6.4, and iterative review from 6R2, 6R3, right? Okay, and handing homework for you next Monday. Okay, and you have to remember that the next week we will have the second exams. Okay, second exam. You also did do exams at home. And next week I will review all the things from chapter 4 to chapter 6, and I also give you the sample test, okay, the sample exams for you to practice. The second exam will be similar to the sample test, okay? So please look at the sample test. I will post on campus, okay? Any questions so far about this? Okay. So now I will make the attendance for you. Sonia, Laurel, Xavier, Kylie, Poppy, Christopher, Wallace, Shaylee, not here, Robin, okay. Bennett, Abdul Hafiz, John Meter, Triplet, Lee, okay, Joe, not here, Madeline Powers,
Here.
Ordelia, Alondra, Matu, Reed, okay, Tyler, here, Maria Smith, Yassi, Sullivan, Thomas here, Tyron, Thomas, Shreya, Wally,
Here.
okay. Cameron Waller, Arthur, Tyler, okay. So the last class we learned how to calculate the probabilities of the standard normal distribution, not normal distribution, standard, by using the table, right? Using the table. Okay, hope you guys have the table in your hand. When you buy the book, you will have the table here. Okay, so it's very useful for you to calculate the probabilities of normal distribution. Okay, so last time we focused on the standard normal distribution. So now we will learn how to find the probabilities using the normal distribution, not standard. Okay, the standard distribution here is just the mean is 0 and the standard deviation is 1. But now we will focus on how to calculate the normal distribution. Okay, the general normal distribution, not standard. Okay. Okay. And the key to calculate the probabilities of the normal distribution is using the table here. Using the table here to and remember that the areas, okay, the areas, something like this. For example, the area of this region is equal to probabilities of x is less than a. Okay? It's areas. Okay, so to find the area of this region, you can find the probability of this Okay. And now we have four popular kind of probabilities problems. Okay, four types of. The first one, the probabilities of the variable is less than a value. That's the first one. Okay, in this kind, you just use a table to find the probabilities. Okay, and the second kind is the probabilities of the variable is greater or equal some values. Okay. In this case, we use the probabilities to 1 minus to this one. Okay, because the total area is 1, so you need to find this, and you can find the probabilities of x is greater than x. That is the second kind. And the third kind is the probabilities of the random variable will between two values. Okay, this is maybe the probabilities x prime and b. So for example, this is exactly the areas. For example, here maybe A to B. So it is exactly the probability of x between two values here. Okay, that is the first case. The final one here is the probability that the random variable will be less than one value or greater than another value. That is the probability like this. That means the probabilities of A, okay, x greater than A or x less than B. Maybe it's x belongs to this one or x belongs to this regions. We have four kind of probabilities, and I told you how to calculate these these kind of probability in the previous class. In the case the standard is scale of the standard normal distribution. That means that we only consider the case when mu equals 0 and the sigma equals 1. We only focus on this, right? We only focus on this. And now we will focus on the case that mu and sigma are general. That means mu and 0 may not, okay, mu may not 0 and sigma may not be 1. Okay, we will focus on this. We will focus on it in this lecture today. Okay, that's the thing we will focus today. Okay. Before I move on to the example, I will give you some steps to do that. Okay. How to find the probability of x less? Okay, find the probability. Distribution variable. Okay. Probability of normal distribution. Okay, not standard. Not necessarily standard. Okay, we have some steps here. Okay. The first step was step 1. Okay. Okay, step 1. You need to change the x values to the z value. Okay, this you know this in the section sigma 1. Okay, how to use it? How to do that? You will use the formula z equal x minus mu over sigma. Okay. We use this formula to change from x value to z value. That is the first step. Okay. Step 2. Step 2. Find the probability of z less than z. Okay, or another one, maybe probability of z less than or probability of z greater than z. It depends on the question of depend on the question. Okay, probability of C1 something like this. So on. Okay, that is the step 2. And the step 3, we will use the formula like this. X is less than X, something like this. So E approximately equal to probability of Z less than Z. Something like this. So if you find the probability of Z less than Z, so you can conclude that the probability of X less than X is approximately equal to this value. Okay. But the first step is very important, okay, because you need to change the X value to Z value. When you change this, so you can find the probability in the table here. If you don't change, you cannot find the probabilities of Z. Okay. That is the step. Okay, so now I will give you an example. Okay, for that. Okay, here we have the body temperatures of the adults are normally distributed. Okay, this is the normal distribution, right? With a mean of 98.6 Fahrenheit and a standard deviation of 0.73 Fahrenheit. And what is the probabilities, okay, of a healthy adult having a body temperature less than this number, less than 96.9 Fahrenheit. Okay. Okay, so now we will use this to calculate the probability of this. Okay. Can I erase this? You finished, right? Okay, I will erase this. Okay, now I will go to step by step to do that. The first step. Okay, I will change the X value to the Z value. Okay, here we have, okay, write some assumption here. So we have mu here is the 98.6, right? And the sigma here, okay, this is the mean and this is the standard deviation. The standard deviation is 0.73, okay? And now we have the value here. X here is 96.9, right? Okay, I will change the X value to the Z value, okay, by using the formula. Okay, we have Z here is X minus mu over sigma. Okay, so now I will calculate this. I put X here. Over this number. Okay, and you will get a result. And the drop of is approximately equal to negative 2.3289. Okay. So this is the first one. Maybe okay, maybe you need to write this number. From this to increase number. Okay, this number. Okay, that is Z, right? Is it clear in this step? Okay, the first step here, you need to change the X value to Z value first. Okay. And the step 2, they ask you to find the probabilities of the healthy adult having a body temperature less than this number, right? So we need to remember that the probabilities of X, okay, X is less than 90.6, okay, the approximately the probability of Z less than this number. Okay. So now you need to find the probability of this number. Okay. How to find this? Okay. Look at your table. Okay, I hope you guys have your table on your hand. Okay, find Z. Okay, so find this on the table here. So could you tell me? Okay, what is the probability of Z less than this number? Anybody tell me what is the value of this? Okay. Okay, you are lead, right? Okay, tell me what about the probability? 009. Let's see. Okay, exactly 00099. Okay, this is exactly 000.99. Right? Okay. Okay, yeah, exactly. So how to find this? So you will look at the table here. So look at the Z here, the column here, and find negative 2.3, right? Negative 2.3. And look at the row here to find 0.003, okay? After that, you will make the intersection between them, okay? And the value here is 0.0099. Okay, is it clear? Okay, this is the way to find us. And after that, so you step 3, you will conclude that conclusion. That is the probabilities of the people having a body temperature less than 96.9 is approximately equal to this number. Is it clear, guys? Okay. Okay. Yeah, that is the step 1. Change to this value. And after that, we can loop that. Okay, don't need to write down here. Okay. It's not different. Okay, when you write is equal here or is less than, it's probability is not change too much. Okay. It's a similar, it's approximately equal. Here, so it's like this. Any questions so far about us? Okay. And we will move on to the next example. Okay. The body temperatures of adults are normally distributed with a mean of this number and standard deviation here. And the question is, what the probabilities of healthy adults having a body temperature greater than this number? Okay. So I need a volunteer to go on the ball to do this. Okay. Okay, think about this, and if you want to go on the ball, I will give you the chance. Okay, I give you the points. The lead have 1 point. Who can solve this problem? Who can solve this problem? You can use my table on here on the table. You can use the normal distribution table on the table here, so you can find the probabilities. This is a change for you to practice. Who else? Nobody? Okay. So I will do this. If nobody to do that. Okay, so the first step 1. Okay, so you can see that this problem is similar to the previous one, right? Okay, we have mu here is this 98.6, and the sigma here is 0.73, and x here is 70. And high, okay, I will change the x value to z value. Okay, it's x minus 6 mu over sigma. And now we will put x here. It's minus mu over sigma. Okay, and you will get the result here. So the result here is negative 1.37 approximately. That is the first step when you do this kind of problem. Change the x value to z value. Okay, step 2, you need to find the, okay, look at the question. The question asks you to find the probabilities of the healthy adult having a body temperature greater than this number, right? So you need to find the probability of z greater than this number. Okay? So to find this, you need to find the probability of this number. Okay, so look at the table. Look at the table. Could you tell me what is the probabilities of this number? Okay, Mackenzie, please.
It is, sorry, I had a second.
Okay.
1.37, so 0.0853.
Yeah, exactly. Thank you. Exactly. Okay, exactly. This is the number 0.0853. Okay, this number. Okay. And step 3. Step 3, we will conclude that the probability of the healthy adult having body temperature greater than this number is E exactly approximately this number. E approximately this number. Clear, right? Okay, this is the kind of problem. Okay, you will see. Our question.
So we can use this test when it's greater than,
Huh?
when the sign is greater than, we can use this test?
Yes, exactly. Yeah, thank you. Oh, sorry. Thank you for letting me know. Okay, my mistake. Okay, so it's less than. Okay. Okay, thank you for letting me know. It's greater than. We will not use like this. Okay, we will. Okay, I forgot one step. Okay, it's 1 minus to this number. Thank you for letting me know. So you'll get the point for this. Okay, this is my mistake. Okay, my mistake for this. Okay. Oh, sorry about this. So it's 1 minus to this number when it's greater than. Okay. Picture for this is this, right? Okay. If the probability of the sum number is less than z, that is like this, right? But if you want to calculate the probability of z greater than z, right? Probability of z greater than z, so you need to find the area of these regions. Because the total area is 1, so it's 1 minus to the area of these regions. Okay. So you just get the result. This is 1 minus the probability of z less than or equal this number. Okay, I will write down here for you to understand. The probability of z greater than this number will be equal to 1 because the total area is 1, right? So it's minus to the probability of z less than or equal this number. And the probability of z less than or equal this number is equal to this value. Okay. How much? Okay. So that's my mistake, and you will get the result here. Okay, clear, right? Question? Okay, thank you for letting me know. Otherwise, we will get the wrong result. It's exactly 0.0853. 91.7. Okay. And after that, you will get the conclusion. Step 3. Okay, conclusion is probability of x is greater than this number, equal to this value, approximately, not equal, this value. Any questions so far about this? So be careful when you do the drop. Okay, I make a mistake here. Okay. So now you will see the first step is they change from x value to z value, and after that they will use a table to find us. Here we will look at the problem. Another example. Okay, another example to find the probabilities of the healthy adult having body temperature between two values. Okay, between two values. Okay, in this case, we need to do step by step similarly. Okay, so I will give you some idea first to do that. Okay. I will write down here. Okay, and we have. Okay, here is the variable is of body temperatures. Okay, right here, and here is the you cannot see, right? Okay, you can see. Okay, right here. And here is the normal distribution. Here is standard normal distribution. Okay, and the mean here is 0, and the mu here. Okay, the mu here is 98.6, right? And the sigma here is 0. The sigma here is 1. Okay. The first step here is you need to change all the x value to z value, right? Okay, here we have two x value. X value here is 98, and the second x value here is 99. We have two x value, right? Okay, so now we will change two x value to two corresponding z value. Okay, that's the first step. We have the x value here is 98, right? 98. And we have the second one is 99. And now we will change to the z value here, z1, and change to the z value here, z2. Okay. Okay, we have x1 here is 98, right? And we need to change to z2. Okay. How to do that? You do the same things. Okay. We have x1 is 98, so we change to the z1 here. Use the same formulas. It's x1 minus mu over sigma, right? And now you will replace x1 here is 98 minus to the mean over to the sigma here. Okay, and you will get the result here. 98 minus. And the result here is approximately negative. Okay. Negative 82. Okay. Is it clear this stuff, guys? Okay, that's the first thing. And we have two value x, right? x2 here is 99. And after that you need to change the value here to z2. Okay. It's x2 minus mu over sigma. Okay. And you relate x2 by 99 minus this number over this number, and you will get the result here is approximately 0.55. Is it clear in this step? I will try to write here. Okay, this is step 1. You will change every x value to every z values. Okay, and now we go to step 2. Okay, the question here is ask you to find the probabilities of the healthy adult having a body temperature between 98 to 98 to between 98 to 99, right? That is the question. So the question here is to find the values of x between these numbers. Okay, so it is exactly not approximately equal to probabilities of this value less than z less than this value, right? Because you change 98 to z1, here is negative 0.82. So this number and this number represent for this number, and 99 change to this number, so this number represent for this number. Okay, so to do that, you only focus on how to calculate this guy. Okay, and you will find the result. Okay, and how to find this? Okay, I will erase here. I will erase here. Okay, I will erase here. Next here. Okay, find this value. Okay, and look at the standard deviation here. Okay, so we have to find this value, that means you need to find the areas of this region, right? You need to find the area of these regions. Okay, to do that, we will draw the picture for this. As you can see, the area of these regions will be, okay, I will calculate the area of this region. Okay, the left side of this number minus to the area of these regions. Okay, if I calculate the area of this region and calculate the area of this region and make the difference between them, and I will find the area of these regions. Is it clear, guys? So now you need to find the area of this region, find the area of these regions, and the probabilities of z between these numbers. Can you see my writing? Okay, hope you can see. If you sit far away, maybe you not see. This is the probability of z less than this number minus the probability of z less than this number by using this one. And okay, so now you will look at the table. Could you tell me what is the probability of z less than this number? 0.55. I'll read again.
0.7088.
55. Okay. Exactly 0.7088. Okay. 0. Forgot. 7. Okay. 7. Okay. Forgot again. 0.708. And minus to 0. Okay. Could you tell me what about this value? Okay, Madeline, please.
0.2061.
Okay, 0.2061. Okay. Okay, let me see exactly. Okay. Okay, exactly. 0.2061. And what about this? And you will make the difference between them. And the result will be 0.9027. And don't forget to conclude that the probability of this value is approximately to this value. Okay, don't forget that. And the conclusion here is, don't forget to write conclusion. The probabilities of this value approximately to this value. Okay? Any questions so far about this? Okay, so we'll go to the next examples. Okay, so here you can see the step by step here. I wrote on the PowerPoint. But when I teach you, I don't show the PowerPoint immediately because you maybe not understand what I write step by step, so you can easy understand. Okay. One more. So now we have the body temperatures of those are normal distributed with a mean here and the standard deviation here. And the question here is, what the probabilities of a healthy adult having a body temperature less than this number or greater than this number? Okay, so now we have different kind of questions. With some okay, this one. Okay, so we go to this one. So step one. Step one, I will change the x value to z value again. So now we have two x value. Could you tell me what is the x values in this question? Anybody else? Robin, please.
The 99.6 and 100.6.
Okay, exactly. Thank you. Okay, we have two x value here. So 99.6 and 2 here is 106. Okay, and we have mu here. Okay, we have mu here is 98.6 and the standard deviation here is 73. Okay, and now we will change x1, x2 to c1, c2. And x1 minus mu over sigma. And I will write down here. So it's approximately equal to this value. Okay, it's approximately 1.37. Okay. And Z2 here is X2 minus mu over sigma. And you will replace X2 here. Approximately equal to this value. Is the 2.74. Okay, how y'all see? And now you will see that the question here is, the question here is to find the probabilities of x less than this 99.6 or x greater than 100.6. Okay. We have the x be greater than less than this value, or x is greater than this value. So it's equal. Okay. So it's approximately equal to. Okay, because you change x to z, so you hear z is less than this number, right? Okay. Or z will greater than this number. Okay. So now you will draw the picture for this. So you see that here, okay. 1.79 and 2.74. So the probabilities of this one is approximately is equal to the area of this one of this region plus the area of this region, right? So it means that it's equal to probabilities of this plus the probability of this value. Okay, so I can write down here is exactly the probability of z less than 1.37 plus the probability of z greater than this number. Is it clear this stuff? So now you just focus on how to calculate this and calculate this. But here, okay, this probability is easy, but this guy is greater than, right? So you need to change this to less than. And it's good because it is, okay, this is 1, okay, this is 1 minus the probability of z less than this number. So it's similar to the first one. And now you will find this number and find this number. Okay. So the probability of z less than 1.37. How much? Okay, Maria, please.
Is it 0.9147?
0. Okay. Okay, exactly. 0.9147 plus 1 minus. Okay, Maria. Okay, could you tell me what about this? What are these probabilities of z less than this number? Maria again.
So I found first the probability for 2.734 and I got 0.9969.
Okay, 69 exactly.
And then when I took the one away, I got 0.0031.
Okay, exactly. Okay, yeah, you get the final result also, right? Okay, 0.996. Could you say it again?
Yeah, so when I took away the 0.9969.
Okay, what about the final result?
The final result I got 0.9178.
170. Okay. This guy, right? Okay.
178.
78. Okay. So okay, exactly. And don't forget to conclude that the probability of this guy is equal to this guy. Okay, that's the final one. Okay, I don't write down again, but you can conclude that like the presentation here. So cut the probabilities of healthy adult having body temperatures either less than this number or greater than this number is approximately equal to this number. Okay, when you write down here, so you need to write a conclusion. It is a handy homework. Okay. In the test, you just write down the answer, the final answer. You don't need to write here, but in the handy homework, you should to write it. Any questions so far? Okay, in the second test, I will give you the if you okay not just to if you don't need to submit to me the solution for that, it's fine. If you do on the computer, right, you just write the final answer. But in some cases, when you write down the answer, maybe you make a mistake, but you don't know where the mistake is. So you can send me a solution of your solution on Canvas, and I will give you the partial credit for this, and I will give you the 2 assignment for this. Okay, you don't need to submit the solution for me. Okay, but if you want to get the partial credit for this question, you can submit the question to me. Okay, that's the kind of second test. If you don't submit solution for me, so the hot side will rate for you. We will rate the score for you. Okay, don't need to. Okay, and one more example before we end the class. Okay, we have the body temperature, but those are normally distributed with a mean of this and okay, with the same assumption. And here they ask you what is the probabilities of healthy adult having a body temperature that differ from the population mean by more than one. Okay, so okay. When you look at the question here, that means that okay, I will erase here. The probabilities of temperatures that differ from the mean. Okay, so I have the mean here. The mean here is 98.6, right? Okay, this is the mean, and they ask you that differ from the population mean, right? So it's here by 1. Okay, you minus 1 and you plus 1. Okay. So when you minus 1, so it is 97.6, and you plus 1 is the 99.6. Okay. Right. Okay, that is the question, and they need to find. We need to find the probabilities of x greater than this number or less than this number or greater than this number. Okay. So that's the kind of question you will focus on to calculate this guy. Okay. And to calculate this guy, so this is similar methods. Change the x value to z values and something like this. Do the same things, right? You can see that here. So first one, we need to change the x value to z value. We have two x value here, so we change the z value here. The z1 should be like this, and z2 should be like this. Okay. And now we need to calculate the probabilities of x belong to this region or belong to this region. So it's approximately equal to z belong to this region or z belong to this region. Okay. So now we will focus on this. And here it's the same, the similar I told you before. Okay. And the probability of z less than this number or less than this number is equal to probability of z less than this number plus to probability of z greater than this number. Okay. And after that, you will use the table here to find out the answer here. That's the final example for you. So you can practice. Any questions so far about this? Clear, right? Okay. If you have any question or concern, you can stay in the class and ask me. Okay. Thank you for your attention.